Hi, gems of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice all the entrance exam question papers because all the papers along with the detailed PDF solutions are available there. You may also download our app. The link is available in the description box. So students, today I'll be solving JEE Mains 8 April 2024. Shift 1 paper. I'll be solving the mathematical questions of this paper in this particular video. So here we start with question number 1. Best of luck. Let's start. The value of k, which belongs to the natural numbers for which this integral, n belongs to the natural numbers again, satisfies this equation. All right. So you are having two integrals, I-20 and I-21 over here. Let's write down I-21. Now this can be written as integral 0 to 1 minus x power k raised to power 21 dx, right? So this further can be written as this. I'm splitting this up like this. All right. So now this is what? This can be, this is I-21. Now, this, I'm breaking this up. This is 1 into this. So this will be 0 to 1. 1 minus x power k raised to power 20 minus x power k into 1 minus x power k raised to power 20 dx. Limits 0 to 1. This is what? This is nothing but your I-20 according to this. So I-21 is equal to I-20. Now, let's break this x raised to power k also as this. Okay. Now, let's understand one thing before solving it further. See, let's try and understand with one thing. If I take 1 minus x raised to power k raised to power 21, I take the derivative of it. What this will be? 21 x raised to power k raised to power 20 minus k into x raised to power this, right? Or I'll take this in the denominator, right? So this will be equal to 1 minus x raised to power k raised to power 20 into x raised to power k minus 1. Or taking integral on both the sides, this will be equal to minus 1 upon this into like this. Okay. This is equal to integral of this 1 minus x power 20 x power k minus 1, right? And this is something over here. If I take this as the second function and this as the first function, this is something like this. See, generally, I have just told you for this explanation, you may skip this part. This is just for your knowledge. In the paper, you can directly write down this step as I'm starting from 1 now. This was just for your understanding. So I-21, that is equal to I-20 minus. So I'll write down that step once again. 0 to 1, x into x power k minus 1, 1 minus x power k raised to power 20 dx. So let's take this as the two separate functions. So I-21 is equal to I-20 minus. This will give me x into, what was this equal to? See, this was equal to this. So this is the, you can write it like this, x raised to power 21 upon this minus 21 into k minus into x. Okay, I have written. So integral of derivative of first into this. Correct? dx. So your I-21 is equal to I-20 minus this was the limits, right? 0 to 1. So on putting on the limits, you will have a 0 over here, and this will be minus minus plus, and again a minus over here. So this is this integral of 1 minus x power k raised to power 21 dx, 0 to 1. This is what? This is your I-21 only. right? So this becomes I21 is equal to I20 minus this into I21, right? So I21, 1 plus 21 into K is equal to I20. Or you have 1 plus 1 upon 21K is equal to I20 upon I21. So this makes it I20 upon I21. This is equal to 147 upon 140, 148 upon 147. Right? This is 148 on this. Or you have 1 upon 21K is equal to this. From here, you will get that K is equal to 7. So this is the answer to the question. This is what you needed to find out in the question. You had to find out the value of K. Option D is the right answer. Hope you got that. Let's move to the next question. Question number 2, the sum of all solutions for this equation is, so the equation x power 2x minus 16 into 8 power x plus 48 is equal to 0. If I put x power x is equal to t, so this equation will become t square minus 16 into t plus 48 is equal to 0. So I want two such numbers that will be okay. Minus 4, minus 12 and 4. All right, so t minus 12. So the two factors for t will be equal to 4 and 2. So that means what was your t? That was 8 raised to power x. That may be equal to 4 or 12. So let's do one thing. How can this be written as? This can be written as x is equal to log to the base 8, 4, or x will be equal to log to the base 8, 12, right? So what are you asked in the question? The sum of all solutions. So sum of all solutions is equal to the sum of 2, right? They are added, so that makes log to the base 8, 4 into 12, which is 48. Correct. That was equal to your x. And this can be written as log 8, 8 into 6, or this will be log 8 to the base 8 plus log 6 to the base 8, right? This is equal to 1 and this is it. So this is this is not x, sorry, not x. This is the sum which you were asked, okay? So you have option A. No, sorry, option C. This is the right answer. Hope you got that. Let's move to the next question. Question number 3, let the circles C1 and C2. These two circles, look at them carefully. Okay. Touch each other externally at the point 6, 6. If this point divides the line segment joining these two, C1 and C2, in the ratio 2:1, what is this value equal to? So, okay. So first of all, you have the C1 circle. This is equivalent to x minus alpha, y minus beta is equal to R1 square. From here, you have the center as alpha and beta and the radius R1. It's given. Okay. And the second circle, this is x minus 8, y minus 15/2 is equal to this. So from here, you have the center as this and radius as R2. Okay, let's try and make the circles. So here is your first circle and it's given that it touch each other externally at the point 6, 6. So this is your point 6, 6. Let's say this is the point P. This is the center of the circle. First, this is C1 and this is C2 and this is the center of the circle 8, 15 by 2. Okay. This is R1 and R2. Correct. Now, let's move forward. What we have to find out is this. So I need alpha, I need beta, I want R1 and R2. So first of all, let's find out alpha and beta. You're also given one more thing, that this is being divided. This line is being divided in the ratio 2:1. So that means this is 2:1, right? Over here. Okay. So this is 2:1 ratio. This is your R1 and R2. Hope the figure is clear to you. Now, according to the section formula, you have alpha into 1 plus 8 into 2 divided by 1 plus 2. This is equal to, sorry, 6. This is a 6 point. Yeah. So from here, this is equal to 6. Also, okay, fine. So you will have alpha plus 16 is equal to 18, or alpha will be equal to 2. Now, let's solve for beta. Similarly, beta into 1, 15 upon 2 into 2 upon 2 plus 1. This is equal to 6, or beta plus 15 is equal to 18, or beta will be equal to 3. We got the value for alpha and beta. Now, that's easy, right? Now, just think of a line. This is the line which is having the coordinates 2, 3, and this is the point 6, 6. This is being divided 2:1, and this was your this. This is nothing but your R1 and R2, right? Let's find out R1 now. R1 will be given by 6 minus 2 square, 6 minus 3 square, which is 16 and 9. The answer is 5. R2 will be 8 minus 6 square, 15 by 2 minus 6 square, which is equal to 4, plus this will give me 3 by 2 and 9 by 4. Correct. So that will be giving me one solution 5 by 2. I got the value for R1, R2, alpha, beta. All the values I got. Now, what we have to find out, it was alpha plus beta plus 4 into R1 square plus R2 square. Okay, all the values I have got. Alpha was 2, beta was 3, 4 into R1 was 5. So this is 25 and this is 25 by 4. Okay, so you have 5 plus 125. This is 130. This is the answer to the question. Option B. Hope you got that. Let's move to the next question. Question number 4, let P, X, Y, Z be the point in the first octant whose projection in the XY plane is the Q point. Let OP be gamma, angle between OQ and the positive X axis is theta, and the angle between OP and the positive Z axis is phi. O is the origin. Then distance of the P from X axis is. So, okay. So you have to find out the distance of P. That means, first of all, I have to go with this XYZ thing. Let's start with it. So first thing, O is the origin and P is given by XYZ. So OP vector will be XI, YJ, and ZK. Now you're given that let OP is equal to gamma. So magnitude of it, this will be given by root of this, right? This is equal to gamma, or gamma is equal to this. From here you get gamma square is equal to x square plus y square plus z square. Also, you are given that P point projection of whose projection in the xy plane is Q. So Q is the projection of the P point in the xy plane. Therefore, OQ will be given by xi and yj, right? Now, you're also given that yes, angle between OQ and the positive x-axis is theta. OQ and positive x-axis, this angle is equal to theta, and angle between OP and the positive z-axis is phi. OP and positive z-axis is phi. So this gives me cos phi is equal to z upon this. OP was equal to this thing. So wait. Right. So this is the one, right? So what is this equal to? This is equal to cos phi is equal to z upon gamma, right, from here. And let's solve this one also. We are also given that cos theta, this is the angle between OQ and the positive x-axis. So cos theta will be given by x upon root of x squared plus y squared, because the magnitude of this OQ will be root of x squared plus y squared only, right? And now what is x squared plus y squared? If I'm using this equation, let's say 1. So using 1, you will have cos theta is equal to x upon, this is gamma squared minus z square, right? And what is this equal to? Z is equal to gamma into cos phi, right? This is z. Let's fill in over here. So you will get cos theta is equal to x upon gamma square minus z square. This is gamma square cos square phi. And this is x square. It was x only, right? Okay. This was under the root, right? So for that, I had to do square of it. So this should be square and this should be square, right? Because what I have done, I have to use x square plus y square. So for that, I'm squaring both sides. Squaring and using 1. Okay. So this makes it, this is cos square theta, gamma square. This is 1 minus cos square phi, or cos square theta is equal to x square upon gamma square sine square phi. Or from here you have x square is equal to gamma square cos square theta sine square phi. This is equal to your x square. Now, what you have to find out here? Distance of P from x-axis. So, distance of P, which is this point, from x-axis, this will be given by d is equal to root of x minus x. This will be 0. And this will give me y square and z square only, right? So, this d is equal to root of, see, from 1, what you had, it was gamma square is equal to x square plus y square plus z square, right? Or gamma square minus z square is equal to, just gamma square minus x square, because here I'm having y square plus z square. This is equal to this. So you have gamma square minus x square over here. So this d is equal to root of gamma square. And what was x square? We just solved it using 2. So x square was equal to gamma square sine square phi cos square theta. This gives me gamma outside, and this will be 1 minus sine square phi cos square theta. That's equal to your d. So this is the answer to the question. Let's check with the options now. So 1 minus sine square phi cos square theta. This is the one. Yes, option A. This is the right answer to the question. Hope you got that. Let's move to the next question. Question number 5, the number of critical points for this function is equal to. So you have the function fx x minus 2 power 2 by 3 into 2x plus 1. Differentiating f dash x, this is first function into derivative of second function into derivative of first. Okay, so this makes it 2 into this x minus 2 power 2 by 3 plus 2 by 3 into 2x plus 1 divided by x minus 2 power 1 by 3. Taking the LCM, you will have 6 into x minus 2 because 2 power 3 and 1 power 3 added, it will give you 1 plus 2 by this 2 into it was 2x plus 1. Okay, upon 3 into x minus 2 power 1 by 3. So this makes it 6x minus 12, 4x plus 2 divided by 3 into x minus 2 power 1 by 3, 10x minus 10, 3x minus 2 power this, and this. So looking at this, I have two critical points. First is x is equal to 1 and the second is x is equal to 2. So that means there are two critical points. First option is the right answer. Hope you got that. Let's move to the next question. Question number 6, let fx be a positive function such that the area bounded by y is equal to fx, y is equal to 0 from x is equal to 0 to x is equal to 8 greater than 0 is given by this. Then the differential equation whose general solution is this, where C1 and C2 are the arbitrary constants is. So first thing, according to the question, you have integral from 0 to a, because the area bounded by, so we are talking about the integral from 0 to a. This is equal to a power minus a 4 a square minus plus a minus 1. So now differentiating both sides and with respect to a, this will give me f of a is equal to minus of this and plus 8a plus 1, right? If I change it into x, so this will be minus e raised to power minus x plus 8x plus 1. Let's find out the derivative. So you have f dash x is equal to, it will be, okay, so this will be e raised to power minus x plus 8. Correct. Now, according to the question, you are given here that y is equal to c1 fx plus c2. Y is equal to c1 fx plus c2. So y dash will be equal to, this will be first this derivative and this will be 0. c1 f dash x. So what is your f dash x? c1 into e power minus x plus 8, right? Let's say this is your first equation. Now differentiating again, y double dash. This will be given by, okay, this will be minus c1 into e power this and 0. Okay, so you will have y double dash minus of this thing. This is equal to c1, or c1 will be equal to minus y double dash into e power x. Let's put this value of c1 in this equation number 1. So what you have here is it will be y dash from 1. It will be y dash is equal to c1, which is equal to minus y double dash into e power x into e power minus x plus 8. Correct? So this will give me minus y double dash, because this and this will cancel out, minus y double dash e power x, or this will be y double dash 8 into 8. Okay, so this is y dash equal to. So you will have y dash plus y double dash 8 e power x plus 1 is equal to 0, or you can have it as 8 e power x plus 1 d square y upon dx square plus dy by dx is equal to 0. So now let's check with the options which one is the correct. I have this one. Right. Option C. This is the correct answer to the question. Hope you understood that. Let's move to the next question. Question number 7, let fx is equal to this function. The number of points of the local minima of f in the given interval 0 to 2 pi is. So here's your function fx 4 cos cube x 3 root 3 cos square x minus 10. Let's find out the derivative. This is 2, 12, 4 into 3, 12. Cos square x into derivative of cos minus sine 3 root 3 into 2 into cos x into sine x. This is equal to 0. So let's combine. You will have your 12 cos square x, or I'll write down 12 sine x cos square x plus 6 root 3 sine x cos x is equal to 0. Correct. Let's take 3 root 3 sine x cos x. 1 plus this will be 2 upon root 3, right? Cos x. This is equal to 0. So there are three conditions. First is sin x may be equal to 0, or cos x may be equal to 0, or cos x may be equal to minus root 3 pi 2. So the sign, because it is lying between 0 to 2 pi, right? Let's start it from here. So first, from 0 to pi by 2, it's going to give you a negative value. And positive value till 5 pi by 8, 6, sorry. Yeah. And then till pi, it will again be negative 7 pi by 6, positive, and yes, over here negative and positive, right? See, over here, it looks something like this. Like this. Wait. So it will go from here, it will go positive, then a negative, positive, and negative and positive, something like this. Okay, so these are the 2 points of local maxima. 5 pi by 6 and 7 pi by 6. Hope you got that. Let's move to the next question. Question number 8, let A be given by this matrix. If A cube is equal to 4A square minus A minus 21I, where I is the identity matrix of order 3 by 3, then what is 2A plus 3B equal to? To answer the question, we'll be using the characteristic equation of the matrices. According to that, A minus lambda I is equal to 0. So what is your A matrix after like A minus lambda I matrix? This is 2 minus lambda, here will be 1, here will be 0. A 3 minus lambda, this will be 5, 0, 1, B minus lambda, this is equal to 0. So let's find out the determinant. Here will be 2 minus lambda, 3 minus lambda, B minus lambda, minus 5, minus A. This will be 0. Yeah. So 0 minus B plus lambda, right? My bad, this will be, first of all, this will be multiplied. So this will be B minus lambda minus B. Okay. And plus of 0. This is equal to 0. Now let's open up the brackets inside. You will have here 2 minus lambda, and this will be 3B minus lambda. I'm taking common 3 plus B lambda square minus 5 minus AB plus A lambda is equal to 0, or this will open up the brackets. This will be 6B and then minus 2 lambda 3 plus b 2 lambda square minus 10 minus 3 b into lambda plus lambda square 3 plus b minus lambda cube and plus 5 into lambda minus ab plus a lambda is equal to 0. And this will let's separate the terms of minus lambda cube and lambda square is having this. Then this will be plus lambda square. Here will be b plus 5. Then you have a minus lambda over here. Minus lambda and this is 1 plus 5a, 5b minus 8. Right? And then there will be minus 10, 6b minus ab is equal to 0. Okay. Now let's multiply both the sides by minus 1. So you will have here, this will be lambda cube minus lambda square b plus 5. And this will be plus lambda 1 minus a and 5b. There will be 10, 6b and this. Now this is, I can write like this is being multiplied by 1. This is a constant. Now if I compare it with the given equation, which is this equation, this can be written as a cube minus 4a square plus a plus 21i is equal to 0. So according to that, you have this one. This is a cube and then you have b plus 5 into a square. Wait, my pen tab is hanging. Give me a minute. Okay, so this is b plus 5 into a square and then you have 1 minus a plus 5b into a and this is plus 10 minus 6b plus ab identity matrix, right? This is equal to 0. So if I compare this, this is definitely 1 and b plus 5, this is equal to 4 according to the question, because the general equation, the given one was a cube minus 4a square minus a plus 21 plus a plus 21i is equal to 0. So this becomes b plus 5 is equal to 4 and then you have 1 minus a plus 5b is equal to 1. 10 minus 6b plus ab is equal to 21. So from here you get b is equal to minus 1 and this will be 1 minus a minus 5 is equal to 1 or a will be equal to minus 5. I got the value of a and b. So what do you have to find out? A came out to be minus 5 and b came out to be minus 1. So 2a plus 3b, this is equal to 2 into minus 5, 3 into minus 1, which is equal to minus of 13. Option B is the right answer. Hope you got that. Let's move to the next question. Question number 9. If the shortest distance between these two lines is m upon root of n, where the greatest common divisor between both of them is 1, what is the value of m plus n? So you are having two lines over here. This is the first one, L1, and the second one is L2. So your L1, this can be written as 2i plus j, 3k, lambda I minus 3j plus 4k. And the second line, L2, this can be written as 2i, 3j, 5k plus mu into 2i, 3j plus k. Correct. So from here, what you get is A1 vector is 2ij, 3k, and your A2 vector 2i, 3j, and 5k. What is A2 minus A1? This will give you 2j plus 2k vector. Similarly, this is your B1 and this is B2 vector. Correct. So let's write it over here. You have B1 as I minus 3j, 4k, and B2 vector 2i, 3j, and k. So what is the cross product of both of them? This is ijk. This is 1, minus 3, 4, 2, 3, and 1. Right. So this one solving will give you I minus 3 minus 12, j 1 minus 8, k into this. So this is minus 15i, 7j, and 9k, right? Magnitude of the cross product of B1 and B2, this is root of minus 15 square, which is 225, 7 square 49, 9 square 81, right? So on solving this will give you root of 355. Now the shortest distance D, this is given by magnitude of A2 minus A1 into dot product with cross product of B1, B2 divided by the magnitude of B2 and B1. Okay, so this gives me, what was your A2 minus A1? Let's write it. This is 2J, 2K, 2, what is that? 2J, 2K? Yes, 2J and 2K. This is minus 15I, 7J, and 9K divided by root of 355. So this makes it minus 15 plus 14 and 18. Sorry, there is no I over here, right? So this will be 0 because I is missing. So it will be 0. And this is divided by 355, which is equal to 32 upon root of 3 upon 55, which is equivalent to this. From here, you get M is 32 and N is M is 32 and N is equal to 355. So the sum of both of them, this is 387. This is the answer to the question. Option B is the correct answer. Hope you got that. Let's move to the next question. Question number 10. Let the sum of two positive integers be 24 if the probability that their product is not less than 3 by 4 times their greatest positive product is m by n, where the greatest common divisor between both of them is 1. What is the difference between the two? So let the two numbers be x and y. So according to the question, you have x plus y is equal to 24, right? And see, first of all, the sample space for the two numbers which will have the sum of 24, this sample space will be given by, see, this is your straight line, right? So this represents your x and this represents your y. This is the line x plus y is equal to 24. So this line can have how many points over here? This can have like it can have 23 comma 1. This is the point. This is the point 0 comma 24 and this point 24 comma 0. So this can have this point which will lie between this 23 comma 1 because I can't take a 0 for any of one of the numbers. And then you have 22 and 2. So on, it will go on till 1 and 23. So how many pairs will be there? This is your 23 pairs. The sample space is going to have your 23 such pairs are possible. Now, next thing, it's saying if the probability that the product is not less than 3 by 4 times the greatest positive product. That means this is not less than means this is greater than, equal to, correct? So for the maximum product, you know that the AM is greater than equal to GM. AM is x plus y upon 2 greater than equal to root of x into y. And this is 12 square. This gives you x into y is less than equal to 144. Now, according to the question, you have to pick such numbers that their product is not less than, or you can say their product is greater than equal to 3 by 4 times their positive product. So this is the maximum positive product, right? Greatest positive product. So 3 by 4 of greatest positive product. So according to that, therefore, xy should be greater than equal to this, which is 108. So you want two such numbers such that their product is greater than equal to 108. Now pick up those ones from this sample space which are having your product greater than equal to 108. So this was your sample space. The above one was your sample space. Now your favorable cases. How many will be these? You are going to have 13, 11, 12, 12. Then this 15, right? And it is 11, 13 also. Okay, I'll write down later. This is 16, 8, 17, 7, 18, 6, and 6, 18, 7, 17. This 9, 15, and 10, 14, 11, 13. Right. How many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 cases. Okay, so you have 13 pairs over here. So total ones were 23 and the favorable ones are 13. So the required probability becomes this. This is equal to m upon n, and the difference between the two is 10. So this is the answer to the question. Option D is the correct answer. Hope you got that. Let's move to the next question. Question number 11, if sin x is equal to minus 3 by 5, where x is lying in the third quadrant, pi 2, 3 pi by 2, it is lying in the third quadrant. You know, in the first quadrant, you have all positive. Here, the sine is positive, tangent positive, and the cosine positive. Okay, so it is lying in the third quadrant, and you are asked about the value for this expression. Easy, very easy, because you are given sin x already. Okay, and you have to find out the tangent and the cos x. So when you have the sine x as minus 3 by 5, you know that cos x will be given by root of 1 minus sine square x. This is 1 minus 9 by 5, 9 by 25, right? This is 4 by 5. See, now I told you already that in the third quadrant, you have the tangent is positive. So that means the cos is positive. So cos is going to give you minus 4 by 5. And what is tangent equal to? Tangent x will be equal to sine upon cos. So minus 3 by 5 minus 4 by 5. This is equal to 3 by 4. So very easy question actually for you. You have to find out 80 tangent square x minus cos x. This gives you 80 into 3 by 4 square, minus of minus, like it will be plus 4 by 5. Or this will be 80, 9 by 16, 4 by 5. Okay, so on solving this whole thing, you will get the answer 109. So this is the answer to the question 109. You have first option as the correct answer. Hope you got that. Let's move to the next question. Question number 12, let ix be given by this integral. If I of 0 is equal to 3, you have to find out I of pi by 12. So you have the integral as 6 dx sine square x 1 minus cot x whole square dx. Let's do one thing. Divide the numerator and the denominator by sine square x. So this will be cosecant square x divided by 1 minus cot x whole square dx. Let's put this is equal to t. So you will have a cotangent x derivative. This is minus cosecant, minus minus will cancel. So this is minus, this is cosecant square x dx is equal to dt. So your integral becomes 6 dt upon t square, which is equal to minus 6 upon t plus the constant c. Now you're given what you're given, I of 0 is equal to 3. This was your I of x. So I of 0 is equal to 3. What will give you, okay, I have to fill in the value of x also, right? So this is equal to minus 6, 1 minus cot x plus c, correct? So this is equal to minus this 1 minus cot x plus c is equal to 3, or you will have cot of 0 right over here. This is cot of 0, and this is 0. So you will get the value of c as 3. Let's fill in this equation. You have ix. Now what your ix becomes? This is minus 6, 1 minus cot x plus 3. Okay. You have to find out in the question I of pi by 12. So this is minus 6 upon root of cotangent of pi by 12 plus 3. This gives you, let's take 3 over here, and this will be minus 6, 1 upon cot of pi by 12. This is 2 plus root 3. This gives me 3 plus 6 upon root 3 plus 1. So this is equal to 3 into root 3 plus this upon root 3 plus 1. Or this will be equal to, this is, okay, 9. So let's take this 3 outside. Root 3 plus, here will be 3 upon root 3 plus 1. Or I'll do one thing, I'm gonna take this thing outside. That will be better, right? This will be root 3 plus 1 over here, and root 3 plus 1 over here. This will cancel, and you will have 3 root 3. This is the answer to the question. Now let's check with the options. 3 root 3, option B. This is the right answer to the question. Hope you got that. Let's move to the next question. Question number 13, the equation of two sides AB and AC of the triangle ABC are these two, respectively. The point this divides the third side BC internally in this ratio. What is the equation of the side BC? So let's say this is your triangle ABC, A, and this is B and C. The equation of A is 4x plus y is equal to 14, and this is 3x minus 2y is equal to 5. Any point, let's say x1, y1, which is lying on this line, this will be given by, if I say this as x1, what will be y1? This will be 14 minus 4 x1. Similarly, if I take any point x2 on the C, on the line AC, that is the point C, so it will be given by 3x2 minus 5 upon 2. So these are the coordinates for BC. I want to find out the equation of BC. I have generally found out the coordinates for BC. Also, you are given that there is a point D which divides BC in the ratio, internally in the ratio 2:1. The coordinates of D are given to you. Easy question, right? You have to just apply your this section formula, right? So according to that, this question, you have, I'm applying this section formula. According to that, you have 2x2 plus x1 upon 3, that is 2 plus 1, this is equal to 2. And from here you have 2x2 plus x1 is equal to 6. Let's say this is the first equation. And the second one, similarly, you have 2 into 3x2 minus 5 upon 2 plus 14 minus 4x1 upon 3 is equal to minus 4 by 3. This 3 and this 3 will cancel. This and this will cancel. So you have a 3x2 minus 5 plus 14 minus 4x1 is equal to minus 4, or you have 3x2 minus 4x1 is equal to minus 13. Okay. So let me check.
Yeah, this is correct. So this is your first equation and this is your second equation. Let's multiply this equation by 4 and subtract. So you will have here 8x2 and 4x1 is equal to 24. Right, subtracting minus, minus, minus. This will, sorry, this is already no need to do the minus thing. Okay, so that was equal to your 24 and this is 11. X2 is equal to 11. That gives you x2 is equal to 1. And you will solve to get x2 is equal to 1. You will solve to get x1 is equal to x2, x1. Yes, x1 is equal to 4. It will come. Okay, so what is your point B become? B was x1, 14 minus 4x1, and C point was x2, 3x2 minus 5 upon 2. So the B point becomes here, this is 4 and this will be minus 2. Similarly, the C point, this will be 1 comma minus 1. So I got the points. Very easy to find from the equation. Equation of BC, I'm using y minus y1 m into x minus x1. Okay, so let's say this minus y minus minus plus 2 is equal to m, the slope, which is minus 1 plus 2 upon 1 minus 4, multiply x minus of x1. Wait, this is minus 1, this. I have to write a y over here. Sorry. So y plus 2, I'm using this. Y plus 2 is equal to the slope, and here will be x minus 4. Okay. So this is gonna give you y plus 2 is equal to minus 1 by 3, x minus 4. Or you will have 3y plus 6 minus x plus 4, x plus 3y plus 2 is equal to 0. This is the required equation of the line. X plus 3y plus 2 is equal to 0. You have C option as the correct answer. Hope you got that. Let's move to the next question. Question number 14. Let t in the square brackets be the greatest integer less than or equal to t. Let a be the set of all prime factors of 2, 3, 1, 0. And f be a function from a to z. Be the function fx is equal to this. Then the number of one-to-one functions from a to the range of f is. So first thing, you are given the number 2310. So the number 2310, let's write down the factors of it. This is 231 into 10. So the factors will be 3 into 11 into 7 into 2 into 5. That means A will be having the elements 2, 3, 5, 7, and 11. What is your function? This is log to the base 2 x square, and here is x cube upon 5, like this. Okay, so first thing, f of 2, this will be equal to log 2, and here will be 4 plus 1, right? Because this is 4 square upon 2 cube, that's 8 upon 5. That will give you 1 point something. So according to this, this is the function which gives you the integer less than equal to. So I will take a 1 value for this. This gives me log to the base e5. Similarly, f3, this will be equal to log to the base 2. And here will be 9 plus 27 by 5. That gives you 5 point something. So I'll be taking the lesser value. This will be 14. F of 5, this will be log to the base 2. 25 plus 125 upon 5, this gives you 25. So you have a 50 over here. Similarly, f of 7 and 11. This gives you log, on solving the whole, you will get a 117 log to the base, log this, and log to the base 2, 117, and this is log to the base 2, 387. Okay. Now, this is equal to 2, 3, 5, 6, and 8. So, your range will be given by 2, 3, 5, 6, 8. So this is having your 5 elements, and this one also was having your 5 elements. Therefore, the number of one-to-one functions will be 5 factorial. Number of one functions, this will be 120. So this is the answer to the question, option B. Hope you understood. Let's move to the next. Question number 15, let Z be a complex number such that the modulus of Z plus 2 is equal to 1 and imaginary part is equal to of this complex number is equal to 1 by 5. Then you have to find out this value. You are here having Z plus 2 modulus. This is equal to 1. And imaginary, give me a minute. Okay. Imaginary of Z plus 1, Z plus 2 is equal to 1 by 5. Let's say Z plus 2 is equal to cos theta plus iota sine theta. So 1 upon Z plus 2, this will be given by cos theta minus iota sine theta, right? So Z1, Z plus 1 upon Z plus 2, this can be written like this, right? So this will be 1 minus cos theta iota sine theta, right? And okay, so this is equal to 1 minus cos theta plus this. Now, this is given into question that, no, not this is equal to, you are given in the question that imaginary of Z plus 1 upon Z plus 2, this is equal to 1 by 5. So, what is imaginary part? That's sine theta. That is equal to 1 by 5. You can get the value of cos theta from here. This will be equal to 1 root of 1 minus sine square theta, which is equal to this, or 24 upon 25 under the root. This will be the value for cos theta plus minus, or this is plus minus 2 root 6 upon 5. I got the value for cos theta. Now, let's get back what we have to find out. I have to find out the real part of Z plus 2 conjugate. So first thing, what will be your Z plus 2? The real part of it and the conjugate. This is what you need to find out. Now, what is your Z plus 2 equal to? Z plus 2 equal, in the starting, we assume that is equal to cos theta plus iota sine theta, right? The real part of this is cos theta only. So the modulus of it will be the magnitude of this cos theta, which is equal to this 2 root 6 upon 5. Correct? So this is the answer to the question. D option. Hope you got that. Let's move to the next question. Question number 16. If the set R has these elements A, comma B, these are the ordered pairs such that A plus 5B is equal to 42 and AB belong to the natural numbers, has M elements, and this where okay, this I represents your root of -1. Then what is M plus X plus Y? Okay, actually this should be iota only. Okay, let's go. So first thing, let's pick up the set R. Here you are given, you have to find out such numbers such that A plus 5B is equal to 0 and AB belong to the natural numbers. Let's start with B is equal to 1. If B is equal to 1, you will solve and get A becomes 37. If B is equal to 2, A will be 32. B will be 3, 4. In this case, this will be 27. And in this case, you are seeing that they are decreasing in 5. So this will be 22, 5, 6, and it will be 17, 12, B7, A will be equal to 7, and B is equal to 8, A will be equal to 2. Further things, further like A and B, they are not possible because then it will go in the negative, right? So these are how many elements? You have total of 8 elements in this, and that's your M. I got M. Okay, we got 8. Now let's pick up the second one. So the second one says summation from N is equal to 1 till M. M was 8. 1 minus iota power n factorial is equal to x plus iota 1. Now listen to one thing, that when you have n greater than equal to 4, you will surely have iota power n factorial is equal to 1, because if I'm saying 4 factorial or above, like greater than 4, so in that case, you will surely have iota's power 4, and iota power 4 is equal to 1. So that will give you a 1 only, right? So anything iota raised to power n factorial for n's value greater than equal to 4 will give you this iota power n factorial is equal to 1 only. So now this will be reduced to 1. You will have iota 1 minus iota 1 factorial, and then you will have 1 minus iota power 2 factorial, 1 minus iota power 3 factorial. Okay. So this is 1 minus iota, and iota square is equal to minus 1. Iota raised to power 6. This will be iota raised to power 6. So this is iota power 4 plus iota this. This is 1 and this is minus 1, right? There's a multiplication. So this is this. This is 1 and this is multiplied by minus 1. So this is minus 1 minus minus will be plus. So you have 1 minus iota plus 2 plus 2, right? Or 5 minus iota. Now you were given that this is equal to x plus iota y. This gives you x is equal to 5 and y is equal to minus 1. So what do you get as x plus y plus m? X was equal to your 5, y was minus 1, and this is equal to this. So you will get 12 as the answer. B option, right answer to the question. Hope you got that. Let's move to the next question. Question number 17, for the function fx is equal to cos x minus x plus 1 for x belonging to real numbers between the following two statements. This is the first statement, fx is equal to 0 for only one value of x is this. And second statement, fx is decreasing in this and increasing in this interval. Fine. So first thing, the function, this is cos x minus x plus 1. So derivative minus sin x minus 1. So this is sin x plus 1. You know, sin x lies between minus 1 and 1. So the maximum negative value it can have is minus 1. Maximum positive value it can have is this 1, right? So in any case, this is decreasing. So this is negative. So f is decreasing function for all x belonging to the real numbers. And you have f of x is equal to 0. First thing, and if I say f of 0 over here, this will give you 2, correct? And what will give you f of pi? This will be equal to minus of pi. Now, therefore, the function is decreasing. Function is decreasing in this interval, and the product of these two functions, this is also negative. So only one solution for fx is equal to 0. Therefore, only one solution of fx is equal to 0. That makes your first statement to be correct and the second one to be incorrect. Okay. We have B option as the right answer. Hope you got that. Let's move to the next question. Question number 18, the set of all alpha for which the vector A, which is given by this, and the vector B are inclined at an obtuse angle for all t belonging to R. So here you have the two vectors. First one, A alpha into T, 6, J and 3K, and the B vector, this is Ti, 2J minus 2 alpha T, K. Right. Now you're given that they are inclined at an obtuse angle. So that means for an obtuse angle, first of all, if I take the dot product of A and B, this is equal to the magnitude of them multiplied by the cos of angle between them. Now you're given that they are making an obtuse angle. So that means cos theta will be negative. Yeah, cos theta will be less than 0. It will be a negative 1. So that means this dot product will be, because this is positive for sure, and there that means this dot product is also negative. Right, let's find out the dot product. This will be given by alpha t square minus 12, 6 alpha t. This is also less than 0 for all t belonging to the real numbers. Now, there are two cases. If alpha is equal to 0, in that case, minus 12, this is for sure less than 10. Right, that's true. If it's not 0, then if it is not 0, then of course this, because this will be this will, and this will give me alpha should be less than 0. If alpha is not equal to 0, then alpha should be negative value only. It can't have a positive value. Okay. So because this will give you a positive value, right? So alpha needs to be a negative value only. The maximum value for this expression, maximum value of alpha t square 6 alpha t minus 12 less than 0. Here, the maximum value for that, you have minus d upon 4a. This should be negative. D is your discriminant. And in this case, discriminant, and a is your alpha in this case. So this gives it, discriminant is b square minus 4ac. Remember the general formula for the discriminant. So this will give you b square, which is 6 alpha. So 36 alpha squared minus minus plus. This will be 48 alpha upon 4 alpha. This is minus, right? It was minus over here. So I will change it into positive, right? Great. Then the sign will change. Or you will have from here like 9 alpha plus 12 is this greater than 0, or you will have alpha as greater than minus 4 by 3. Therefore, alpha will belong to minus 4 by 3 and 0. Okay, so this is the interval minus 4 by 3, 0. This is a 1. Option C. Hope you got that. Let's move to the next question. Question number 19, let y is equal to yx be the solution for this differential equation. Let's see, 1 plus y square into this plus this is equal to 0, y of 0 is equal to 1. Then y 5 by 4 is equal to. All right, so let's write down. You have 1 plus y square e power tangent x dx cos square x 1 plus this dy is equal to 0. Okay, so next, let's separate the dx and the dy terms. So you have e power tangent x into dx is equal to minus cos squared x 1 plus e power 2 tangent x dy. Here I'm writing this also. So let's segregate the x and the y terms. So you will have here integral of 1 upon cos square x into e power tangent x 1 plus e power 2 tangent x dx is equal to 1 upon 1 plus y square into dy. Okay, so this can be written as, this is, I'm taking cos in the numerator. This is secant square x e power tangent x upon 1 plus 2 tangent x dx, and this integral, this is equal to tangent inverse y plus c. Okay, so this is, see again, this is the tangent inverse of e tangent x. This is tangent inverse of e tangent x, and here was your minus, right? I forgot to put this, so this is this, and let's take it on the right hand side, left hand side. This is equal to c. Now you're given in the question that y of 0 is equal to 1. That means when I put x is equal to 0, wait, what was that? Y of 0 is equal to 1. So that means when x is equal to 0, y is equal to 1. So this gives me tangent inverse 0, and this is tangent inverse 1. This is equal to C, right? And this is tangent inverse 0. This is 0 only. So this is tangent inverse 1 plus tangent inverse 1. So 2 tangent inverse 1 plus C is equal to, wait, that was equal to a C. Okay, so this makes it 2 tangent inverse 1. So that is 2 into pi by 4. This is equal to pi by 2. So C is equal to pi by 2. What does your equation becomes now? Equation will be tangent inverse E power tangent X tangent inverse Y is equal to pi by 2. Let's put X is equal to pi. Okay. So what will you have? This will be, I have to find out Y of pi by 4. Okay. So I'll put it pi by 4, not pi. This will be tangent inverse E part tangent of pi by 4, that is equal to 1 plus tangent inverse Y is equal to pi by 2. So this becomes tangent inverse Y is equal to, this will go on this side, right? And it will be cot inverse E. Okay. Yeah, this will go on this side and this will become cot inverse T. So from here you will have Y is equal to 1 by E. So option C is the correct answer to the question. Hope you got that. Let's move to the next question. Question number 20. Let h be equal to this equation. This is the hyperbola which has a centricity as the root of 3, length of the latest rectum as this. Suppose this point alpha comma 6, where alpha is positive, it's lying on the hyperbola. If B is the product of the focal distance of the point this, what is alpha? Not B, sorry, this is beta. What is alpha squared plus beta? So let's rewrite this hyperbola equation. I can write it as x square upon a square minus y square upon b square is equal to minus 1. Eccentricity for this will be given by 1 plus b square upon a square upon b square. So you are given this is equal to root of 3. That gives you this is equal to 3, or a square upon b square is equal to 2, or the latest rectum. Let's go to that. Or you can have what is the latest rectum? 4 root 3. Okay. So this is, latest rectum is 2a square upon b. This is equal to 4 root 3. All right. From here, you have a square is equal to 2b square. So 2a square, or 2a square, this is equal to 4b square upon b is equal to this 4 and 4 will cancel, b will be root 3. And you will solve, you will have the a will be equal to root of 6. Now we have the hyperbola equation. Again, this is x square by 6, y square by 3 is equal to minus 1. Now you're given that this point lies on the hyperbola alpha 6. So this makes it alpha square upon 6 y square, which is y square, what is 6? Okay, so this is equal to this, or you have alpha square minus this is equal to minus 1. Alpha square is equal to 66. Okay, what we have to find out is beta is the product of the focal distances of the point. This, what will be the focus given by? So focus over here will be given by this. So the two focus will be positive and the negative ones. B was equal to root 3 and what is B equal to root 3? Yes, B was equal to root 3 and your eccentricity is also root 3. So root 3, this will be 3 and minus 3. These are the two focuses. And alpha comma 6 point will be given by alpha was the, wait, yes, alpha comma 6. This will be this point, correct? And the distance, you can say d1 will be given by root of 66 minus 0 square, 6 minus 3 square. This is again root of 66 minus 0 square, 6 plus 3 square. This gives me 66 plus 9, which is equal to 75 under the root. And this is equal to 66 plus 81, which is 147 under the root, right? What you have to find out is beta is the distance, right? So alpha squared plus beta, you have to find out. Beta is the product of the focal distances. So beta is equal to d1 cross d2 root of 75 cross root of 147. This will be 25 into 3 into 3 into 7 into 7, or 5, 3 and 7. This will give you 105. This is your beta. You have to find out alpha squared plus beta. Alpha square was this and this is this. So the answer will be equal to 171. This is the answer to the question. Option B. Hope you got that. Let's move to the next question. Question number 21. Let A be given by this matrix if the sum of the diagonal elements of A power 13 is 3 power n. What is n equal to? You have the A matrix 2 minus 1, 1 and 1. You find out A square. This will be 2 minus 1, 1 and 1. Okay. This will be equal to 4. Let's show first. Yeah. So this will be 4 minus 1 and this will be, so second column minus 2 minus 1 and 2 plus 1 and minus 1 plus 1. This will give you 3 minus 3, 0. Okay. So what will be A cube equal to? I don't need A cube. Let's jump to like A power 4. I think that will be better, right? And this can be written 3, 1, 1, minus 1 and 0. So what will be A power 4? This will be A square into A square. So 3, 1, minus 1, 1, 0 into 3. This. Okay. This will give me 9, 1, minus 1 and minus 1 and 0, 1, 0, minus 1, 0. Or you will have 9, 0, minus 1, 1 and minus 1. So let's jump to A power 8. This will be 9 into 9, 0, minus 1, 1, minus 1, 0, minus 1, 1, minus 1. Okay. So this will give me 81. This will be 0, minus 1, 0, plus 1, 0, minus 1, and minus 1 plus 1. This will be 81, minus 1, 1, this, right? So this is the answer for A power 8. Now I have to find out A13. For that, I'll be doing A power 8 into A power 4. I'll get A power 12. So what was A power 8? It was 81 and A power 4. This was into 9. So this is minus 1, 1, minus 1, 0. And A power 4 was 0, minus 1, 1 and minus 1. This gives me 729. This will be 0 plus 1, 1 minus 1, 0, 0, 1, 0. So 729, 1, 0, 0, 1. Identity matrix actually I got, right? So what will be A13 now? A13 will be equal to A12 into A, or this will be 1, 729 outside this, and your A matrix was 2 minus 1 this. So this is 729, 2 plus 0, minus 1 plus 0, 0, 1, 0, 1. So 729, 2, 1, minus 1, and 1. Let's do the multiplication. You will have a 8, 5, 1, 4, 7, 2, 9, minus this. Now, what sum you have to find out was of some of the diagonal elements of this is 3 power n. So let's find out the sum of the diagonal elements. Let's add both of them. 1, 4, 5, 8, 7, 2, 9. You have 7, 8, 2, 1. So sum of diagonal elements, this is equal to 3 raised to power n. This is 3 raised to power 7. So that gives you n is equal to 7. Okay, this is the right answer to the question. You got the value of n as 7. Hope you got that. Let's move to the next question. Question number 22. If the orthocenter of the triangle formed by these lines is the centroid of another triangle whose circumcenter and orthocenter respectively are given to you as this and this, you have to find out the modulus of the difference of A and B. See, the sum is not that tough, only they have twisted the sum a lot. It is saying you orthocenter of the triangle formed by these 3 lines. You are given the 3 lines. Let's say this is the point A, B, and C. This is the point A, which is 2x plus 3y minus 1 is equal to 0. This is your point B. This is your point C. Now, this is x plus 2y minus 1 is equal to 0. And this is the third line, which is ax, by minus 1 is equal to 0. A is the point of intersection of these 2 lines. First of all, let's find out the A point. So this will be 2x, 3y minus 1 is equal to 0. Multiply this equation by 2 and subtract. You have 2x, 4y minus 2 is equal to 0. So you will have minus y plus 1 is equal to 0. Y will be equal to 1. And you will solve, you will get the corresponding value of x is equal to 1. So A point becomes 1 minus 1. This is first thing. Now, analyze the problem. It is saying you orthocenter of the triangle is orthocenter of this triangle. Let's say this is the orthocenter of the triangle. Let's say this is G. This is the centroid of another triangle. There is one more triangle. This is the centroid of that triangle whose circumcenter and orthocenter are given to you. So let's consider only, these 3: centroid, circumcenter, orthocenter. They are collinear. They are they are lying in a straight line. So if I take this C1, this one to be your circumcenter, let's say this is your circumcenter, and this is your H, this is your orthocenter. So this is your centroid. Okay. So let's say circumcenter as C. C's coordinates 3, 4. And orthocenter is your this, which is having the coordinates as -6, -8. And G is your centroid, which is, I don't know the coordinates, but I know one thing, that centroids divides the circumcenter and the orthocenter in the ratio 1:2. Right? According to that, I can find out the coordinates for G. So this will be given by 2 into 3, 6 minus 6 upon 3 and 8 minus 8 upon 3. So that means this centroid lies on the origin. So this centroid was what? It was the orthocenter for this triangle ABC. That means I got the coordinates for G. Okay. Now, think of it carefully. I have the A coordinates, I have the G coordinates. Let's find out the slope of AG. Slope of AG. This will be given by 1 minus 0 upon minus 1 minus 0, which is equal to 1. Now, what will be the slope of BC? This will be minus 1 upon slope of AG, or that will be equal to 1. I got the slope of BC. Any one point now, if I get for BC, my work will be done. Okay, let's try and find out that point on BC now. For that, I already have the equation for AC, but I don't have the equation for BC. Let's try do something else. Let's try and find out the equation for CG now. Okay. I have the coordinates for G. Let's find out the slope of CG. So what will be the slope of CG? For that, let's find out slope of AB. Slope of AB. This will be equal to, the equation was 2x 3y minus 1 is equal to 0. So y will be equal to minus 2 by 3x plus 1 by 3. So this is the slope. Minus 2 by 3. Slope of CH. No, it was CG. It was CG, right? CGC, this is perpendicular because this is the orthocenter. CG is perpendicular to AB line. So slope of CG will be minus 1 upon slope of AB, which will give you 3 by 2. I got the slope of CG, correct? Now, what is the, let's frame the equation of CG. This is y minus y1 is equal to m into x minus x1. I have a CG is passing through 0, 0 origin. So y minus 0 is equal to 3 by 2 x minus 0, or y will be equal to 3 by 2x. This is the equation of CG. I already have the equation of AC. This is x plus 2y minus 1 is equal to 0. Let's find out the point of intersection. So this will be given by x plus 2 into 3 by 2x minus 1 is equal to 0, or this will give me x as 1 by 4. So you will correspondingly find out the value of y as 3 by 8 from here. So therefore, C point will be given by 1 by 4 and 3 by 8. Okay, now this C point lies on BC, and I already have the slope of BC. We calculated that, that's equal to 1. We can easily frame the equation of BC now. So this will be given by y minus 3 by 8 is equal to 1, x minus 1 by 4, or 8y minus 3 upon 8, 4x minus 1 upon 4, or this will be 8y minus 3, 8x minus 2, or you have minus 8x plus 8y minus 1 is equal to 0. If I compare it with the given equation, you have A as minus 8 and B as 8. Okay, so you have to find out mod of A minus B. That gives you 16. This is the answer to the question 16. Hope you got that. Let's move to the next question. Question number 23. 3 balls are drawn at random from a bag containing 5 blue, 4 yellow balls. Let the random variables x and y respectively denote the number of blue and the yellow balls. If x bar and y bar means the means of x and y respectively, you have to find out 7x bar plus 4y bar. So let's say your x and y represents the yellow and the blue balls. Okay. So this is representing, x represents your blue balls and y represents your yellow balls, right? So probability that you withdraw all the 3 blue balls, 2 blue balls, 1 blue ball, or 0 blue ball. In the case you withdraw all the 3 blue balls and 0 yellow, here will be 1 yellow, here will be 2 yellow, here all the 3 will be yellow. So these are the probabilities, right? What is x bar? That is summation x px, and y bar is summation y p of y. Now, probability that all the 3 blue balls and no yellow ball, this is equal to 5c3 into 4c0 divided by out of 9, because 5 and 4, this is 9, so 9c3. This gives you 5c, this is equivalent to 5. Okay, wait. This is 5 into 4 upon 2 into 1. And this is 9c3. That is equal to 9 factorial upon 3 factorial into 6 factorial. Okay. This gives you 10 upon 9, 8, 7 upon 6, and this is 3, this is 4, this is this. So this gives you 5 upon 42. Okay. Next, if you pick up 2 blue balls, 1 yellow ball, then this probability 5C2, because 5 blue balls, you are picking up 2 blue balls, and from 4 yellow balls, you are picking up 1. So this is divided by 9C3. This will give you, on solving, 10 upon 21. Similarly, you are picking up 1 blue ball and 2 yellow balls. This will be given by 5C1 multiply 4C2 divided by 9C3. This is equal to 5 upon 14. And you pick up no blue ball, all the 3 yellow balls. This will be given by 5C0, 4C3, 9C3 divided by. Okay. That gives you 4 upon 84 or 1 upon 21. So now x bar, this is equal to, let's see, x bar will be equal to 3 into px. So this will be 3 into 5 by 42, 2 into 10 upon 21, 5 upon 14 into 1 plus a 0 into this. Okay, so this will be, let's take the LCM, 42. And this will give me 15, and this will be 40 and 15. So this is x bar. 7x bar, this will be equal to into this, or 70 upon 6. And now y bar, this will be equal to 0 into 5 upon 42, 1 into 10 upon 21, 2 into 5 by 14, 3 into this. Let's take the LCM again. 42, here will be 20, 30, and 6, which is equal to 56 upon 42. Or what you had to find out for y was, let's check, it was 4y bar. So 4y bar, this is 56, 42 into 4 to 21. And let it be like this only, okay? Let it be like 56 upon 42 only, and leave it. This is 2, 1, 1 upon 21, right? So 7x bar, 4y bar, this is equal to 70 upon 6, 112 upon 21. So here the LCM will be, it will go at 3, 2, and 7. So this will be 21, 42 again. Okay. So this is 7, 490 plus 2, 2, 4. This is 2, 1, and 7 upon 42. So 714 upon 42, on solving, this will give you 17 as the answer. Okay. So here is the answer to the question, 17. Hope you got that. Let's move to the next question. Question number 24, the number of 3-digit numbers formed using these digits when the repetition of digits is not allowed and which are not divisible by 3 is equal to. So here you want the numbers which are not divisible by 3. The divisibility test of 3 says the sum of the digits should not be divisible by 3. So divisibility test is sum of the digits should not be divisible by 3. Digits should not be divisible by 3. So the total number of 3 digits number which are not divisible by 3, if I look at them, these pairs will be 457, 347, 257, 247, 245, and 235. Right? 6 such numbers are there. Now, each of them contain 3 numbers. So what are the total number of ways? that will be 6 into 3 positions. So this is 3 factorial. That's 36. So this is the answer to the question 36. Hope you got that. Let's move to the next question. Question number 25. Let the positive integers be written in this form 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. If the kth row contains exactly k numbers for every natural number case, if this is the first row containing 1, second row containing 2, third row containing 3, fourth row containing 4 numbers, then the row in which this number 5310 will be is, first of all, let's say that this number lies in, let this number lie in the kth row. So first element of kth row will be given by k into k minus 1 upon 2 plus 1. Look over here. This is the third row. So this is 3 into 2 upon 2 plus 1. That is equal to 4. And the last element, this element will be given by k into k plus 1 upon 2. This one. So look at the general one. This is 1, 3, 6, 10. Similarly, over here, the last element of the kth row, this will be given by k into k plus 1 upon 2. Now, this 5310 number, this will lie between these two numbers only. Anywhere, maybe from here, or maybe this number, or between these numbers. Now, according to the question, this 5310 will lie between k into k minus 1 upon 2 plus 1 and k into k plus 1 upon 2, right? So let's solve it. Let's solve them for separately. K into k minus 1 upon 2 less than equal to, this will be 5309, or k into k minus 1 less than equal to, this will be this. And over here, this will be k into k plus 1. This is greater than equal to 10620, right? So square minus k minus this is less than equal to 0, and k square plus k minus this is greater than equal to 0. So combining both of them, ignoring the inequalities, you will get that k square minus k minus this is equal to 0. This is equal to 0. Wait, this is 10620. Okay. So let's add them. You will have 2k square is equal to 21238, or k square will be equal to 10619. K will be equal to root of this, which will be 103. So this is the value of k, 103. That's it. So kth row, it lies in the 103rd row. Hope you got that. Let's move to the next question. Question number 26. If the range of the function f theta, which is given by this, where theta belongs to the real numbers, is alpha beta, this is the range of the function, then the sum of the infinite GPU's first term is 64 and the common ratio is alpha upon beta is equal to. So basically you have two parts of the question. The first part, I'll calculate alpha and beta and use that to solve the second part. Let's go. Here you have f theta is sine power 4 theta 3 cos square theta divided by sine power 4 theta plus cos square theta. Let's break up the numerator. This can be written as 1 plus 2 cos square theta upon sine power 4 theta cos square theta. So this is equal to 1 plus, let's open up the denominator. This can be written as cos power 4 theta minus cos square theta plus 1. So dividing the numerator and the denominator by cos square theta, this will be equal to cos square theta, and here will be minus 1 plus secant square theta, or 1 this cos square theta, this, and minus 1 over here. Okay, so all right. So that means you can't have the cos theta is equal to 0. Cos theta cannot be equal to 0. Also, you know one thing, that cos square theta plus 1 upon cos square theta, this is always greater than equal to 2, right? So that means if I subtract 1 from it, minus 1 will be greater than equal to minus 1. So this will have the range from starting from 1 to infinity, right? And because this is in the denominator in this part, correct? So therefore, 1 upon cos square theta plus 1 upon cos square theta minus 1, this will belong from 0 to 1 limit. Okay. So for that, let's get back to our f theta. What was that? F theta was 1 plus 2 upon this value. Okay. So there can be two possible value, the f theta minimum and maximum, right? So this can be 0. So if this much portion, this becomes equal to 0, then the minimum value will become equal to 1. And if this becomes 1, then the maximum value will be equal to 3. These are the minimum and the maximum values, right? Therefore, the range will become 1 to 3, right? It will be belonging to 1 to 3. So that makes your alpha as 1 and beta as 3. Now, let's move towards our GP thing. In the question, you are given that the first term for the GP was 64. Common ratio R, that is equal to alpha upon beta, which is equal to 1 by 3. So sum of infinite series, this is given by A upon 1 minus R. So 61 minus 64 minus this, which gives you 64 upon 2 by 3, or this is equal to 64 upon 3 by 2. And that's 96. 96 is the right answer to the question. Hope you got that. Let's move to the next question. Question number 27. Let alpha be given by summation r is equal to 0 till n 4r square plus 2r plus 1 part, not part. This is into NCR, and beta is the summation from r is equal to 0 to n NCR by r plus 1 plus 1 upon n plus 1. If 2 alpha upon beta lies between 140 and 281, then you have to find out the value of n. Let's start with alpha. You are having alpha as this 4 r square 2r plus 1 into NCR. This can be written as 4 summation r is equal to 0 till n r square, and NCR, I'm breaking that NCR now, that will be written as n by r into this NCR minus n minus 1 CR minus 1 plus 2 summation r is equal to 0 till n r into again n minus r n minus 1 c r minus 1, and let this one be as such. So this is equal to 4n. I'm taking outside, summation r is equal to 0 till n. You have here let it 4n into n plus 1. I'm applying the direct formulas over here. So 4n into n plus 1 into 2 power n plus n minus 2 in plus 2 into n into 2 power n minus 1 plus 2 raised to power n. Or let's take 2 raised to power n common. This will be n into n plus 1, and here it will be n plus 1 only. And this will be 2 power n plus 1 whole square. So this is your alpha. And what is your beta? Beta was summation r is equal to 0 till n NCR upon r plus 1 in plus 1 upon this. Or this will be equal to summation r is equal to 0 till n plus 1 upon CR, n plus 1 CR plus 1, because I have utilized this R plus 1. Now this will be divided by n plus 1 plus 1 upon n plus 1. So this will be equal to, I'm taking, 1 upon n plus 1 common. This will be 1 plus this. So on till n plus 1, C n plus 1. Right, this is nothing but 1 upon n plus 1, 2 raised to power n plus 1. So this is your beta. You have to find out 2 alpha upon beta. So this is equal to 2 raised to power n plus 1 upon n plus 1. And what is your beta? That was equal to 1 upon 2 power n. And this will be over here. So this and this will cancel. And you will have 2 power n plus 1. And this will give you minus n into 1 plus n. Or this will be 2 into 1 plus n. Sorry, this is wrong. I have filled in wrong values for alpha and beta. So let's start it from here again. You have to find out 2 alpha upon beta. And what is your 2 alpha equal to? It was this, right? So this makes it 2 into 2 power n plus 1 whole square. And the beta, it came out to be 2 power n plus 1 into n plus 1 will go over here. This will make it n plus 1 cube because this will cancel with this and this will be n plus 1 cube. Now, in the question, what you are asked is this 140 to 81. So this will be 140 to, that was 2 less than equal to or less than. So there is this sign 2 alpha upon beta is less than 281. So 140 lies n plus 1 whole cube lies between 281 and this. So if I put n is equal to 4, then what will be the value of n plus 1 cube? That's 125. For 5, this is 6 cube, and that will be 216. And if I put n is equal to 6, 7 cube, this is 343. So the value of n for which this lies between 140 and 281 is n is equal to 5. So this is the answer to the question, n is equal to 5. Hope you got that. Let's move to the next question. Question number 28. Let A, B, C be these given vectors. And R is a vector such that this expression is true and this is true. You have to find out the value for this expression. Let's write down. You have A, B, C vectors. I'm picking up from here itself. You have A as 9I minus 13J, 25K. The B vector 3I, 7J minus 13K. And the C vector 17I minus 2J plus 3K. So first thing, I need a B plus C over here. Let's solve it. B plus C, this will be given by 20I, 5J, 12K. And the difference between B and C vector, this will be minus 14I, 9J, minus 14K. So your R vector minus, it is, see, first of all, let's pick up this vector only. You have this thing, R cross A is equal to this. So this can be written as R vector minus B plus C cross A. This is equal to 0, right? So you will have R vector is equal to B plus C plus lambda A, or R vector B plus C we calculated, that was 20I, 5J minus 12K plus 9. A is this, right? So this gives me 20 plus 9 lambda I, 5 minus 13 lambda J, 25 lambda minus 12 K. Now you're also given that the dot product of R and B minus C vector is equal to 0. So now R dot B minus C is equal to 0. So R dot minus 14I 9J minus 14K is equal to 0. So what you have to find out is, okay, you have to find out this. First, let's dot multiply these two vectors, right? This will give you minus 14, 20 plus 9 lambda, 5 minus 13 lambda, 25 lambda minus 12 is equal to 0. On solving, this will give you minus 593 lambda minus 67 is equal to 0, or lambda will be equal to this. Minus 67 upon 593. Therefore, R vector is equal to B plus C minus this vector. Okay. And modulus of 593 are 67A upon 593 square. This is equal to B plus C square, or this is equal to, this was minus 12K, right? So this will give you root of 20 square, 5 square, and 144. Okay, so actually this is the square, so I will leave the root. Fine, that gives you 425 and 144, which is 569. So this is the answer to the question 569. Hope you got that. Let's move to the next question. Question number 29, let the area of the region enclosed by the curve y is equal to this and the x-axis between x is equal to minus 5 to pi be given by a. Then what is a square equal to? So this figure represents the problem. You have to find, you have given that the y is minimum of these values between the x-axis for minus pi over here to pi. All right. So let's go. All right. So the required area A, this will be given by, it will be minus, from minus pi to minus 3 pi by 4, I'll be taking cos x dx. From minus 3 pi by 4 to 0 sin x, 0 to pi by 4 sin x dx, and from pi by 4 to pi by 2, it will be cos x dx, and from pi by 2 to pi, it will be cos x dx, right? So let's solve it. The integral of cos, this is sine minus pi minus 3 pi by 4, and this will be minus plus 3 pi by 4 minus, and here will be 0, and this is minus outside. This will be plus cos x 0 to pi by 4, and sine x, here will be minus, right? Pi by 4 to pi by 2 minus sine x pi by 2 to pi. This will give you minus of minus 1 by root 2 minus 0 plus 1 plus this minus this minus 0 minus 1. Let's open up the brackets. 1 by root 2 plus 1 plus 1 by root 2 minus 1 by root 2 plus 1 minus this and plus 1. So these two will this cancel, And you will have the a value as 4 and a square will be 16. All right. So you have 16 as the right answer to the question. Hope you understood that. Let's move to the next question. Question number 30. This is the last question of this paper. It says the value of limit x approaching 0 2 into this equation is equal to what? So, all right, let's write down the equation first. You have, I'll start from here itself, the equation given to you. This is limit x approaching 0 and 2 1 minus cos x into cos 2x power 1 by 2 cos 3x power 1 by 3 so on cos 10x power 1 by 10 whole thing divided by x squared. See, this is 0 upon 0 so form. So, you know what we have to do? I'll apply the L hospitals. Okay. So, according to that, you will have this limit 2. I'm taking outside x approaching 0 sine x cos 2x 1 by 2. So on it will go like first function or rest of the function to derivative of first. So on till cos 10x raised to power 1 by 10 plus. So here will be something. Now I'm finding the derivative of the second function. Here will be sine 2x into the first is cos x into cos 3x power 1 by 3, so on. So this thing will continue 10 times, right? Ultimately, and this denominator, this will have 2x. Ultimately, what you will have is this will be equal to limit this 2 and this 2 will cancel x approaching 0 and this will give you sine x. A minute, this will be sine x upon x and the rest is cos 2x power 1 by 2 and so on plus sine 2x upon x into like cos x cos 3x power 1 by 3 so on. This will continue till sine 10x upon x into cos x and so on. Hope you understood this thing. Okay. And I have utilized the denominator x also. So this is limit x approaching 0. Here will be, see, this will, I'm approaching them 0. The cos of 0 is equal to 1. So I can ignore that. This will be limit x approaching. This will be reduced to limit x approaching 0 sine x upon x plus sine 2x upon x so on sine 10x upon x, right? Now what I need to do, I need to have a 2 over here. So here will be 2. I need to have a 10 over here. So here will be 10, right? And so this will give me 1 plus 2 plus 3, so on till 10. And you know, this is n into n plus 1 upon 2. So the answer is 55. Okay. This is the answer to the question. Hope you understood that. So students, with that, we have completed all the 30 questions of this paper. Hope you understood them well. And don't forget to visit our website, www.examsnet.com. Here you will find all the entrance exam question papers along with the detailed PDF solutions for free. For a better preparation, you must download our app. The link is available in the description box. So students, keep shining, keep rising high. That's all for this paper. A very best of luck for your exams. Bye.